Hypothesis testing is a type of statistical analysis that tests an assumption which applies to a population like the mean, variance, or independence of variables. There are two kinds of hypotheses: null hypothesis HO and alternative hypothesis H1. The assumption we want to test is called null hypothesis HO. Alternative hypothesis H1 is the opposite of null hypothesis HO. After calculating the test statistic, reject HO or not reject HO, we never say accept HO because HO is an assumption. It's not the fact. So we never say accept HO. Key points to remember: a test statistic is always calculated based on the assumption that the null hypothesis HO is true. Let's talk about HO and H1. Since all the test statistic and p-value are calculated under the assumption HO is true, normally HO is connected with the following words: being equal, such as no difference, the same, no change, or equal to. H1 is opposite. It's connected with inequalities, such as not equal to, greater than, less than, different from, changed after something. For HO, we use the words follow certain distribution, such as normal distribution, binomial distribution, and uniform distribution. Uniform distribution means every possible outcome has an equal chance of happening, like standard die and so on. Opposite to HO, H1, we always use the word doesn't follow certain distribution, like the coin is biased. For HO, we always say no relationship between variables, or the variables are independent of each other. Opposite to HO, H1, we always use the word there is some relationship between variables, or the two variables are dependent on each other. Practice 1. Write down null hypothesis HO and alternative hypothesis H1. Hypothesis testing is a type of statistical analysis that tests an assumption which applies to a population, keywords, population, such as mean, variance, or independence of variables. In other words, when we write down HO and H1, we have to use population mean or population variance. Question 1. We want to test whether the mean height of 8th graders is 66 inches. First step, we need to check what we are testing. The mean height of 8th graders is, keywords here, is 66 inches. So this is a HO. Since we are testing on the mean, you need to add population mean. Then H1 will be the opposite. HO, the population mean height of 8th graders is 66 inches. H1, the population mean height of 8th graders is not 66 inches. Question 2. We want to test whether the mean height of 8th graders is higher than 66 inches. Since this is talking about mean, don't forget you need to add a population. The population mean height of 8th graders is higher than. Higher than means not equal to. So this is H1. HO will be the population mean height of 8th graders is equal to 66 inches. HO, the population mean height of 8th graders is 66 inches. H1, the population mean height of 8th graders is higher than 66 inches. Question 3. We want to test whether the mean height of 8th graders is lower than 66 inches. Lower than means not equal to 66 inches. So this is H1. HO, still the population mean height of 8th graders is 66 inches. For HO, the population mean height of 8th graders is 66 inches. H1, the population mean height of 8th graders is lower than 66 inches. Question 4. We want to test if a coin is biased. The coin is biased, keywords biased. This go to H1. HO will be the coin is not biased or the coin is fair. Question 5. We want to test if a die is fair. Fair, this word is related to HO. H1 will be not fair or biased. HO is the die is fair. H1, the die is not fair or the die is biased. Let's go to question 8. Anita decides to use a hypothesis test to determine if the mean weight, keywords mean, so don't forget population, of the fish changed after construction of the factory. Changed means it's different from before. So this is H1. HO will be the population mean weight of the fish didn't change after construction of a factory. Question 9. The owner of the orchard wants to know whether the mean weight of the apples from tree A is different from the mean weight of apples from tree B. Since we are given mu A means the population mean of tree A. Mu B, the population mean of tree B. HO will be mu A equals mu B. H1 will be mu A. It's not equal to mu B. Question 10. The company wants to determine if the new drug is more effective at decreasing cholesterol than the old drug. More effective means not equal to. So this is H1. HO will be the new drug is as effective at decreasing cholesterol as the old drug. Question 11. Isaac carried out a hypothesis test to see whether the types of journeys are dependent on the weather. Dependent on, this is the keywords for H1. So HO will be the types of journeys are independent of the weather. H1 will be the types of journeys are dependent on the weather. Question 12. A hypothesis test was used to determine whether salad meals are independent of a person's position. Independent, this is the keywords for HO. So HO will be salad meals are independent of a person's position. H1, salad meals are dependent on a person's position. Let's go to 13. A dice manufacturer claims that a novelty die he produces is biased. A hypothesis test is conducted to determine if the manufacturer's claim is true. Check what's the manufacturer's claim. He claims that the die is biased. Keywords is biased. Biased is the keywords for H1. So H1 will be the claim is true. HO will be the claim is not true, which means the die is not biased. HO, the manufacturer's claim is not true, or the die is fair. H1, the manufacturer's claim is true, or the die is biased. 14. A calculator generates a random sequence of digits. It's claimed that all digits have the same probability of appearing in the sequence. A hypothesis test is conducted to determine if the claim is true. What's the claim? The claim is that all digits have the same probabilities of appearing in the sequence, which means the probability follows a certain pattern. This is HO. In other words, HO will be the claim is true. H1 is the claim is not true. So HO is the claim is true. H1, the claim is not true. Or for HO, you could say all digits have the same probability of appearing in the sequence. H1 will be all digits do not have the same probability of appearing in the sequence.